In this video, we will discuss integrated rate law and what's the difference from the previous differential rate law and this method is that instead of using multiple experiments and changing the concentration, here in this integrated rate law, there will be only one experiment and the concentration changes over time is measured for that experiment. What is that means is integrated rate law is concentration versus time and only one experiment. Whereas in the differential rate law, it is concentration versus rate. And we will have multiple experiment. And in each trial, we will get a different rate for that experiment. And in each trial, we will change the concentration of the reactants. So for integrated rate law, the time and the concentration are related for a zero order reaction through this equation. Concentration A equal negative kT plus concentration A0. For the first order reaction, the concentration and time are related. Log concentration A equal negative kT plus log concentration A0. And for second order, 1 over concentration A equal kT plus 1 over concentration A0. So here, all are in the form of standard linear equation, that is y equal mx plus b. And we can see that concentration A is the concentration after certain time t, and concentration A0 is the initial concentration of the reactant. So when you plot the graph of concentration versus time, you will get a linear graph with a negative slope for the zero order. And if you plot a graph natural log concentration over time, for the first order also we are going to get a negative slope graph. Whereas for the second order, when we plot inverse the reciprocal of concentration versus time, we will get a linear graph with a positive slope. And in all these cases, even though we have negative slope and positive slope, when we take the value of k, it's going to be the absolute value. We are not going to say the negative of that number. In all cases, we will just say the absolute value. Let us see an example here, how to solve this problem, let us see. So, at 400 degrees Celsius, first order conversion of cyclopropane into propylene as a rate constant of 1.16 times 10 to the power negative 6 second inverse. If the initial concentration of cyclopropane is 1 time 10 to the power negative 2 moles per liter at 400 degrees Celsius, what will its concentration be 24 hours after the reaction begins? So what we have to do, we will just note down what are the given and how can we go ahead and solve for the unknown. So what I will do, first I will write what is given. First we have the rate constant K, which equal 1.16 times 10 to the power negative 6 second inverse. And then time is also given, which is 24 hours. So what I will look here is the unit of K is in second, whereas the time given is in hours. So we cannot use different units for time. So what we will do, we will convert that into seconds. So how can you convert 24 hours into second is, so we know in 1 hour 60 minutes and in 1 minute we have 60 second. So what hour and hour will cancel, minute and minute will cancel. So we just have to multiply 24 times 60 times 60. That will equal 86,400 seconds. Okay, so that conversion is done. And what else is given is concentration is given, initial concentration is given. So that is 10 to the power negative 2 moles per liter. So what are we supposed to find? What to find is concentration of the reactant after time that is 24 hours. So since it is already given, it is first order, we can use the formula for the first order reaction, that is natural log A equal negative Kt plus natural log concentration A0. So now we have to substitute the values given into the formula. So that is log concentration A, that's what we have to find. And we have K value given, which equal 1.16 times 10 to the power negative 6. And that we have to multiply with the time in seconds, 86,400. And we have to add that one to our initial concentration, logarithm of initial concentration, that is 10 to the power negative 2. So when you plug it in the calculator, you can see that 1.16 times 86,400 equals 0.1 when you multiply with the 10 to the power negative 6. That we have to add with the, so I will just put ln in the calculator, click on ln and type 10 and to the power negative 2. That's how I will put it in the TI-83 or 84 calculator, and we will get negative 4.61. And now we will add these two numbers. So log concentration A equal negative 4.71, and then from log A we need just concentration A. So what we have to do, press second in the calculator and then press ln, and then it will show you a button with the E. It will blink, and then we will enter e to the power negative 4.71, and that will equal our answer, concentration A, that equals 0.009 molar. That will be our answer. Let's see another question. Cyclopropane rearranges to form propane in the gas phase. So what we have to do here is we have to write like in the previous case what is given. So since this is first order reaction, we can use the formula, the same formula from the previous one, concentration log concentration A equal negative Kt plus log concentration A0. So this is first order, and then we have rate constant given. So rate constant K equal 3.36 times 10 to the power negative 5 second inverse. And also we have the molarity, that is the initial concentration given 0.0445 molar, and the time is also given 235.0 minutes. Again, it is in minutes, but the unit is in second here for the rate constant. So I have to convert that minutes into seconds by multiplying the 60. That will give you this answer. And we have to find initial concentration. So what we have to do, we just substitute in the formula. So that is log concentration A equal negative 3.36 times 10 to the power negative 5 times the time, and then natural log 0.0445. And now plug it in the calculator, the first numbers, and you will get 0.47376, which is negative. And if you take the natural log of 0.0445, we will get negative 3.112. And now that is log concentration A equal 3.585. That will be negative, and we have to find the concentration of A. So e to the power negative 3.585, that equal, I'll be getting 0.0277. So that is how we can calculate. So now let's see a little different question. Here is another question. In this question, calculate the initial concentration. So this is a different type of question. Calculate the initial concentration. That means we have to find A0. How much is that? And it is given 5.7 minutes. So that means I have time 5.7 minutes. Final concentration minutes for it to reach a final concentration of 0.15. That means I have after certain time this 5.7 minutes the concentration is 0.15 molar and the rate constant K is given 2.5 times 10 to the power negative 3 m inverse second inverse and since it is second inverse, I had to convert the minutes. That means time I had to convert 5.7 times 60. That will give me 342 seconds. And now which formula I will use? It's not mentioned which order this reaction is. So, but I know the K, the rate constant, and I have the unit given. So from the unit, I will figure it out. So the formula should be for second order. So the formula is 1 over concentration A equal Kt plus 1 over concentration A0. So now I have the values. I just substitute that and then 1 over concentration A is 0.15 that equal 2.5 times 10 to the power negative 3 is the K value times time is 342 second and then 1 over concentration A0. That's what I have to find. So when you plug it in the calculator, we will get 1 over 0.15 is 6.67. And when you multiply these numbers, we will get 0.855 plus 1 over concentration A0. And then 6.67. I will take this, I just want to isolate 1 over A0 on the right side. So on both sides, I can subtract 0.855 that equal 1 over concentration A0. So that will give me 5.815 that equal 1 over concentration A0. I need concentration A0, not 1 over A0. What I will do, I will just flip it. What is this means is 0.815 divided by 1. Correct? So when I flip it, what I will get? I'll get 1 over 5.815 that equal concentration A0 divided by 1 that will equal 0.172. That's the answer and the unit will be molarity m.